So my name is Ryan McGinnis, and I am an assistant professor in biomedical engineering here at UVM.
My name is Aaron Jeline, and I'm a fourth-year medical student here at the University of Vermont College of Medicine.
Multiple sclerosis is a neurodegenerative disorder that affects balance and mobility. Oftentimes people with MS are at increased likelihood of falling. Falls are really bad in MS because one of the most effective treatments is exercise. And if people fall, often they get injured and they can no longer exercise, which causes a negative spiral in their symptoms. So it's really important that we prevent falls in this population.
My role on this project has really been to advise the engineering team here at UVM. What this device really helps us quantify is, how an individual's status is changing throughout the progression of this disease.
Dr. McGinnis has a vision for a proactive solution to this problem, intending to employ just-in-time interventions using wearable sensors and mobile devices to help prevent falls in high fall risk populations. Not only may this help improve the quality of life of those living with MS, but it may also help to alleviate the $31 billion cost burden on the U.S. healthcare system caused annually by falling alone. Together, C-Team 8 has been tasked with designing and producing the fall mitigation system requested by Dr. Ryan McGinnis.
Hi, I'm Melissa Saib, and I'm a senior studying mechanical engineering, and I'm the safety coordinator and test engineer for C-Team 8.
Hi, I'm Chris Erkson. I'm a senior biomedical engineer, and I'm the financial manager and the manufacturing engineer for the proactive MS fall mitigation system.
Hi, I'm Sierra McConnell. I'm a senior biomedical engineering major here, and I'm the logistics manager for this team.
Hi, I'm Joe Nizzola. I'm studying mechanical engineering, and I'm the project manager for the mHealth Technologies development team.
The main requirements of the client are a robust ergonomic sensor mounting fixture, an observational hardware that is compatible with the communication interface, and a mobile application.
To begin our design process, we met with one of these focus groups with patients with MS to get their ideas on our project. They worried about falling, so if it would help them not fall, then it was definitely something they were into.
A side-load case allows for a slimmer overall profile of the hard casing, as well as a reduced surface area when adhered to the person's skin. Additionally, a side-load case minimizes the risk of the case being inadvertently opened by the user. One trade-off of a side-load case is that it is slightly more difficult for the client to install the sensors within the extremely narrow opening cavity inside the center of the case.
Considering adhesion, we went through several adhesives through manual testing. We all wore several different forms of 3M medical adhesives, and after many long wear tests, selected a double-sided adhesive that had one side specifically for substrate and one for skin. It has succeeded in all of our wear tests, with going up to 11 days at some points.
Trade-offs for the adhesives was that the one that we had selected could only be bought in bulk. A jig was created so the client could easily assemble the patches that would be needed for individual cases without taking an exorbitant amount of their time.
So the sensors that we bought come with an 80 milliamp hour lithium polymer battery that we initially used to meet our requirements of at least 5 days runtime. They weren't passing our tests consistently. In doing some calculations, we realized that it just wasn't enough power. So then we went up to a 150 milliamp hour battery. After doing actual testing, it was passing the test. So some trade-offs for our battery were we had to outsource our soldering, and they could do a micro soldering with a microscope, so it just looked a lot better. Yeah.
Our mobile application has three main components. The first is it has to connect to and stay connected to 2 Bluetooth devices at a time. The second functionality is it has to stream the accelerometer data from both of those sensors simultaneously into our fall risk algorithm and calculate fall risk in real time. And the third is that it has to provide feedback that's readable and understandable to the user itself. We began by wireframing the app out on paper and seeing what all those functionalities would look like as far as going through the app page by page itself, and what kind of user interaction and click you would need to generate all the responses and the functionality behind the app itself. And from there, we basically took that wireframe and converted it into some code and got our final app.
The team in general has done an excellent job in creating a product that really caters to the patient's needs. and really satisfies that goal of hopefully preventing falls in these